Assalamu alaikum everyone. My name is Al Haftab and welcome back to my YouTube channel. Today we will be talking about EdgeBridge project report. EdgeBridge was our semester end project and we built it. Now there is a report and we will review it what we have done in this. First comes the abstract. The object of this project is to create an EdgeBridge circuit utilizing BJTs for efficient and dependable bidirectional control of a DC motor. The bridge is widely used circuit design in power electronics that allows for current flow through a load in either direction. The circuit consists of four BJT transistors configured in a bridge formation with each pair of transistors comprising a branch that can switch the current flow direction. The project will entail choosing suitable transistors, determining the essential component values, and utilizing computer software to simulate the circuit's performance. A physical prototype of the circuit will be built and tested in a variety of operating conditions to verify its functionality. This project aim is to provide a practical demonstration of potential application of BJT transistors in edge-bridge circuits which may have various uses in fields of robotics, automation, and electric vehicles. Introduction. So what basically is an edge bridge? An electronic circuit known as edge bridge can change the polarity of a voltage that is applied to a load. In robotics, the other fields, these circuits are frequently utilized to enable DC motors to move forward or backward. This is the basic diagram of edge bridge. We have four switches, switch 1, 2, 3, and 4. So if we close switch 2 and 3, the current will flow in this direction, moving the motor in counterclock direction. And if we close the switch 1 and switch 4, the motor will turn in clockwise direction because the flow of current will be like this. So using the different switches, we can control the motion of motor. This is how an edge bridge normally works. What were the objectives? Design edge bridge to control the direction of the motor, to protect the circuit, add back EMF protection, component selection and breadboard testing, design a PCB layout and a make development board. So moving on, we made some calculations to provide us with conclusions to which components we should use and what values of them. So base resistor calculation, the base emitter voltage drop of tip 127 and tip 122 is typically around 2 volt. Tip 127 and tip 122 are types of BJTs we have used in this. We will discuss it later. Therefore, if you want to drive them with a 5 volt signal, you need a resistor that drops 3 volt at the base. Let's assume you choose 1K ohm resistor. Current limiting resistor calculation. The maximum current rating of 1N4007 is a diode we have used in this and we will discuss it later. Let's assume you choose a 470 ohm resistor in series with each diode to limit the current. The voltage across the drop across the diode is typically around 0.7 volt. So the voltage drop across the resistor will be 12 volt minus 0.7 volt is equal to 11.13 volt. Okay. So using Ohm's law, the current through the resistor will be 11.3 divided by 470 is equal to 0.024 ampere, which is less than the maximum current rating of the diode. So we use this. Further, these are some more calculations we have used and we have calculated and achieved our results. You can stop the video and look up to it. I'm going to move on. These are some basic calculations like IC max, IC we've used for the BJTs to conclude our answers. IB, currents, R2, R1, the resistor values. We've used these calculations to draw our conclusions. Moving on to the components. We have used tip 127 PNP, tip 122 NPN, DC motor, resistor 10K, 1K, 470 ohms, diodes of 1N4007, PC817, the optocouplers, female headers, and battery. So let's discuss about the components we have used. Tip 127 and tip 122 are types of BJTs we have used. The tip 127 is a PNP positive bipolar junction transistor BJT that is commonly used in power application. It is designed to handle high voltage and high current loads, making it suitable for use in power amplifiers, audio amplifiers, and switching applications. The transistor has a maximum voltage rating of 100 volts and a maximum current rating of 5 amperes. Tip 122 NPN is an negative positive negative BJT that is commonly used in high power switching application. It is designed to handle high voltage and high current loads, making it suitable for use in power regulators, motor control circuits, and other high power applications. The transistor has a maximum voltage rating of 100 volts and a maximum current rating of 5 amperes. This is the diagram of tip 122. Moving on, we have resistors. A resistor is an electrical component that is commonly used in electronic circuits to control the flow of current. It is a passive component, which means that it does not require an external power source to operate. A resistor is made up of a material that has a high resistance to flow of current, electric current, such as carbon, metal, or ceramic. The resistance of a resistor is measured in ohms, and it determines how much the resistor will limit the flow of a current in a circuit. The PC817 optocoupler. The PC817 optocoupler is a small electronic component that consists of an infrared LED and a photodetector. The packaged together in a single housing. The purpose of an optocoupler is to provide electrical isolation between two circuits while allowing them to communicate with each other. When a voltage is applied to the LED, it emits infrared light, which is then detected by a photodetector on the other side of the optocoupler. The resulting signal is then amplified and transmitted to the output circuit, provide a means of electrical isolation. This is a diagram, and this is how it looks like physically. A diagram of optocoupler. One, we have anode, two, we have cathode, emitter, and collector. So it provides the isolation for the circuit. So we have used it to isolate it and protect as from back EMF. Further, we have used diode 1 and 4007. A diode is an electric component that allows current to flow in only one direction. So it is used to protect the circuit from back EMF. It is a two-terminal device consisting of a p-type positive type semiconductor and n-type negative type semiconductors that are joined together. The junction between the two materials forms a depletion region, which acts as a barrier to current flow in one direction. When a voltage is applied to the diode in forward direction, anode to cathode, the depletion region is reduced and current flows through the diode. When a voltage is applied in the reverse direction, cathode to anode, the depletion region widens and the diode blocks current flow. Further, we have DC motor. A direct current motor is a type of electric motor that converts electrical energy into mechanical energy. It consists of rotor, which is one rotating part of the motor, and stator, which is a steady part. The rotor is connected to a shaft that provides mechanical power, while the stator contains the magnetic field that interacts with the rotor to produce torque. Proteus simulation. This is the screenshot of the Proteus. We have used Proteus and also EasyEDA for our simulation purposes. You can also use Proteus or use EasyEDM for both. So this is a screenshot of what we have built in the Proteus. I'm also going to show you in the Proteus software. So this is the circuit diagram, schematic diagram of the H bridge. Here we have used four optocouplers PC817, also the BJTs tip 127 and 122, the diode 1 and 4007, resistors 10K, 1K, 470 ohms. These are the enable pins, the switches, and the 12-volt power here and the power here, and this is the motor. So they are the tip 127, the BJTs are placed or the MOSFETs are placed in such a way that they form an edge. So this is called an edge bridge. The working. An edge bridge is an electronic device that allows you to control the direction of a DC motor or the other DC load such as solenoid or a heater. It is called an edge bridge because the arrangement of four switches, transistors or MOSFETs looks like the letter H. If we observe here, this here forms an edge. So this is called an edge bridge. The edge bridge has four switches arranged in two pairs, one pair on the top and one pair on the bottom. The two switches in each pair are connected in parallel, with one switch connected to the positive voltage supply and the other connected to the ground. To control the direction of the motor, you can turn on one pair of switches while other off pair. If you turn on the top pair and turn off the bottom pair, current flows from positive voltage supply through the top switch through the motor and then through the bottom switch to ground. This causes the motors to spin in one direction. So if you want to spin the motor in opposite direction, you can turn off the top pair and turn on the bottom pair. This causes current to flow from positive voltage supply through bottom switch through the motor and then through the top switch to ground. Then the motor, you can say that it turns in the opposite direction. By controlling the on-off state of the switches, you can control the speed and direction of the motor. For example, you can use pulse width modulation PWM to control the speed of the motor by rapidly switching the switches on and off. Edge bridges are commonly used in robotics, automation, and other applications where precise control of speed and direction of a motor or the load is required. Apart from using the BJTs, you can also use FETs, JFETs, because and also MOSFETs, because the switching speed, if you require switching more than if you require the frequency of switches higher, then you can use MOSFETs because they provide a higher frequency of switches than the BJTs. We have used BJTs because we don't require so much, you can say, switching frequency. That's why we have used BJTs, but you can also use MOSFETs. So this is a data sheet of tip 127 and 122. An electronic circuit, the power switching transistor tip 127 is a PNP, bipolar junction transistor. And how does it work? A large current can flow from emitter to collector terminals of the transistor. When a smaller current is applied to the base terminal, as a PNP transistor, the base of the tip 127 must be negatively biased in relation to the emitter in order to turn it on. So a large current can flow from the collector to emitter when transistor is turned on, acting like a switch, drive loads like motor relays and other electronic devices with this substantial current. Further, we have the data sheet a little elaborate. For PNP types, voltage and current values are negative. Pulse duration is equal to 300 microsecond. Duty cycle is less than or equal to 2%. So here it explains the data sheet is given so you can have the answers to your question if you don't understand the calculations. Two BJTs are connected in series in tip 127, which is a Darlington transistor. The main BJT Q1 is associated with the foundation of second BJT and it intensifies the ongoing streaming into the foundation of second BJT. Let me show you it with the. So these are the BJTs, the tip 127 and 122. The Q1 and Q2 are connected in series and they form Darlington transistors. Okay, so overall tip 127 is a power transistor that works well and is reliable and can be used in many electronic applications. However, it is essential to note that it must be mounted and biased correctly to prevent damage and overheating. So before you place your tip 127 and 122s, you need to you need to find out the configuration of its pin and how it can be placed and how it should be placed so it can have the current and base and collector correctly. So if you place them wrong, it will overheat and in the end damage your circuit. So be sure to check this out before you can place them. So PC817 in this circuit is basically used to isolate the circuit. It can completely isolate the upper and lower circuit without affecting each other. So if I show you the circuit, the schematic, the PC817, we have used for PC817 the optocouplers. So the basic use of this is that it protects the circuit. It keeps the circuit in isolation. Like if the current is flowing in this direction, this and by moving to ground, so it will isolate the upper circuit from the lower circuit, and it will not interfere with each other, and the motor can move in one direction or the other easily without having any effect on each other. Also, we have used the resistors 10K, 1K, and 470 ohms. You all know why resistors are used. They are used for the, you can say, blockage or providing resistance to the flow of current. Further, we have used 1N4007 diode. The diodes are optional in this current circuit as tip 107 and the tip 127 and 122 are those transistors which have diode present in them, but we have used it for greater protection. Testing on breadboard. Yes. So this was the time when we implemented the edge bridge on the breadboard. Here are the BJTs, the optocouplers, some resistors and some jumper wires to implement the edge bridge on breadboard, and it was working completely fine. I will share the video with you too shortly. Further, we use the EDA software, Easy EDA, to create the PCB layout and 3D layout of our schematics. We have used Proteus for the schematic, and for the layout purposes, the PCB layout we have used the Easy EDA. You can use both of them. It's quite user friendly and you will love it. So this was the Pro PCB hardware, the top and bottom side. Here you can see the BJTs, the diodes, the optocouplers, headers, and resistors. So these headers were for the switches, yani, for one switch, for the top switch and low switch. So these were opened for the motor. We place the motor here. This was the bottom side of the PCB sheet. We have used fiber sheet for this. You can either use copper sheet or fiber sheet. I will recommend the fiber sheet. They are little expensive, but they are worth it. Plus, you should use a good soldering wire to have better soldering. So what? Let's figure the applications of edge bridge. Robotics. In robotics, edge bridges are utilized to control robotic movement. Robots can be programmed to move in any direction and carry out intricate tasks by controlling the speed and direction of the motors with edge bridge. Electric automobiles. In electric vehicles, edge bridges are used to control the speed and direction of the motors that power the wheel. The wheel can be driven forward or backward at different speeds by controlling the motors with edge bridge. Automation in industry. In industrial automation applications, edge bridges are used to utilize control the movement of robotic arm, conveyor belts, and other machinery. The machinery can be programmed to move in any direction and at various speeds by controlling the motors with edge bridge. System for renewable energy. In renewable energy system, edge bridges are used to control the speed and direction of the motor that drive solar panels and wind turbines. The efficiency of renewable energy system can be enhanced by controlling the motors with edge bridges. Home computerization. Applications for home automation make use of edge bridge to direct the movement of curtains, window blinds, and other household appliances. These appliances can be automated to open and close at specific times and in particular directions by controlling the motors with edge bridge. So thank you everyone. This is all for today's video. I hope you have enjoyed and you have learned about the edge page, how to build it and how you can use the calculations, how to make the calculations and draw your conclusions. Thank you. Like my video if you enjoyed the video. Thank you. Allah Hafiz.